double prime minus 2y prime plus y equals e to the t. So this is the linear second order inhomogeneous, right? Differential equation. We have to find a particular solution. Find a particular solution. So yes, let's take a look. So we're going to write down, this is the method of variation of parameters. So this is the system of differential equations that we have to solve. V prime y sub 1, v sub 2 prime y sub 2 equals 0. This is the first equation. And the second one with derivatives. All right, so this is the system to use. This is the method of variation of parameters, okay? So variation of parameters. This is the method. So we don't have to derive anything anymore. We derived this system using specific example last time. So this is what you need to put on your index card. This system of two equations. So y sub 1 and y sub 2 here will be solutions, the fundamental solutions to the homogeneous problem. Let's find them. So here is the homogeneous. So this is the corresponding homogeneous. So we have to write the characteristic equation. Do you agree?
Yes.
Excellent. So let's solve this. This one is perfect square. And we have two repeated real solutions. So lambda sub 1 and lambda sub 2 are both equal to 1, which implies from section 4.3, we discussed if you have two repeated real roots, the corresponding fundamental set will be e to the power t, and the second one will be t times e to the power t. So again, this is C section 4.3, how we find fundamental solutions if you know the roots of the characteristic equation. So again, this is the case when we have two repeated real roots, and therefore we're getting two fundamental solutions of this form. Are there any questions so far? Any questions? All right, so next step is, let's start with the first equation. It's usually easier to solve. And by the way, can you tell me what is g of t in this problem? What is your g of t?
E of t?
That's right. Yeah, the right-hand side, excellent. So g of t in this problem, let's keep in mind g of t is the right-hand side. We can also circle this and say this is g of t in our particular example. So we're going to start again with the first equation. So v sub 1 prime, we're trying to find those two, v sub 1 and v sub 2. So v sub 1 prime is going to stay the way it is here. And then y sub 1 is e to the t plus v sub 2 prime times t e to the t equals 0. So this is the first equation. We're going to subtract this term from both sides. and divide both sides by e to the t. So we get v sub 1 prime equals negative v sub 2 prime times t. So this is the relationship between v sub 1 prime and v sub 2 prime. So I'm going to substitute v sub 1 prime into the second equation. So we have negative v sub 2 prime times t, y sub 1 prime. I'll just keep it for now as y sub 1 prime plus v sub 2 prime y sub 2 prime equals g of t. So now I'm going to plug in the derivatives, okay? So negative v sub 2 prime times t. Instead of y sub 1 prime, we have e to the t plus v sub 2 prime times. Instead of y sub 2 prime, I have to write 1 times e to the t plus t times e to the t. And instead of g of t, I'm writing e to the t. Are there any questions?
The way that you're solving this, is it similar to when you have C1 and C2?
That's
but
right.
you just change the, okay.
Yeah. Yes, C1 and C2 has been replaced by V sub 1 of t and V sub 2 of t. This
Okay,
is,
but overall solving it is the same. You're gonna plug in the initial value into the original equation and then the derived equation.
actually, there is no initial value here. This is not given. So we will just identify V sub, well, actually, yeah, this problem doesn't have initial conditions. So we just want to find a particular solution. We don't want to find the entire y of t. We only want to find y particular. If you want to find y of t, then you would have to combine solution to the homogeneous problem plus particular solution. In this problem, the question is find the particular solution only. So this problem is shorter.
Okay, thank you.
Yeah, you're welcome. So again, this problem is easier because they don't want you to find the entire y of t. They only want to find y particular, which is again, it's going to be shorter. There are no initial conditions. We don't have to use them. We just need to find one particular solution. That's all we have to do in this problem, okay? So we should be able to cancel something. If nothing cancels out, something is wrong. So let's see, hopefully. I believe we can cancel here. Yes, this negative term and this positive term. So this is just part of the method. If nothing can be canceled, something is wrong. Usually you should be able to cancel a lot, and whatever is left should be easy to solve. So this is what we have, what's remaining on the left-hand side, and this is the right-hand side. Divide both sides by e to the t. So this is a very nice equation. We can solve it by integration, right? Integration, so we just end up with t. You do not have to add any c. Don't worry about that. So we just want to keep the main part, v sub 2 equals to 2. So once you have v sub 2, you can find a v sub 1 using this relationship here. So we said that v sub 1 prime equals negative v sub 2 prime. And we said v sub 2 prime is just 1, right? V sub 2 prime is just 1. So we're going to plug that in here, and we say v sub 1 prime equals negative 1 times t, which is just minus t. And then we find v sub 1 using integration. And we get negative t squared over 2. This is what I'm getting for v sub 1. Are there any questions?
On the left side, when you canceled, that's when you did the product rule, right?
No, there is no product rule on this side because I just divided by e to the t both sides.
No, not that, above it. So when you did the, yeah, in this area, you just took the product rule?
No, I used this equation here from the index card. This is the second one, right? So we use the first one over here. We use the first equation to find v sub 1 prime equals negative v sub 2 prime times t. And then we substitute this into the second equation here. Instead of v sub 1 prime, I wrote this, right? This is negative v sub 2 prime times t. I substituted instead of this v sub 1 prime. And then we have y sub 1 prime plus v sub 2 prime, y sub 2 prime equals g of t. So this is from the index card, from here.
Okay, got it.
Yeah, so this system should be on the index card. We don't memorize this. This is, we derived it in class using specific example, and now we just want to use it. We don't want to derive it every single time. It's too much work.
Okay, thank you.
You're welcome. So excellent. Let's finally write down our particular solution. Y particular. So we said it's going to, so v sub 1 of t times y sub 1 of t plus v sub 2 of t, y sub 2 of t. This is where we replace c sub 1 by v sub 1 and c sub 2 by v sub 2. So now that we have v sub 1, we can say this is negative t squared over 2 times y sub 1, which is e to the t, plus v sub 2. So v sub 2 is t, right? And y sub 2 is here, t times e to the t. So we have minus t squared over 2 e to the t plus t squared e to the t. These two terms can be combined to give us t squared over 2 times e to the t. So this is our answer. This is y particular, and we're done. This is our this is our final answer. So I'm going to check that with my notes, and yeah, so this is the same. Any questions? Any questions? All right, so now we're going to move to quiz number 5. So quiz number 5 has not been posted yet. Let me, all right, so this quiz number 5 is not available at this point, and the reason it hasn't been tested yet. Let me shrink this screen here. I'm going to begin it. And unlike the previous quizzes, it has 7 questions, and all questions are displayed on the entire screen. It's not one at a time. It's all 7 are displayed at the same time. So the problem I wanted to look at, well, again, I want to warn you that the quiz is ready, but it hasn't been tested. So there is a chance that some of the problems could have some mistakes in them. So we will go over those questions, and if I catch a mistake, I'll just fix it later, okay? So let's start with question number 1. Given is the following DE, find the constant K in one Y particular solution. Round your final answer to 2 decimal places. All right, I'm going to copy this differential equation. So here is the clearly you will get a different version of this this type of problem. So the form of the particular solution is given. This is the method of undetermined coefficients. Do you recognize this? This is section 4.5. From section 4.5. So the particular solution has the same form as the right-hand side of this inhomogeneous equation, except of instead of 14, we have K, right? So round your final answer to 2 decimal places. All right, so I'm going to switch to the paper. So tell me what to do here. Any suggestions?
Take the derivatives of YP.
Excellent, absolutely. So we're going to take first and second derivatives, right?
Right.
Excellent. Very good. So this is the first derivative. Please let me know if you have any, if you see any mistakes, you please let me know. So I'm differentiating the second time. Do you agree?
Yes.
Very good. So I'm substituting those into the differential equation. We know that this is a particular solution, so it must satisfy the DE. So I'm going to write, this is Y double prime, then I'm going to add 3 times first derivative. So that's 21, right?
Yes.
Thank you. 18 times, now I put KE, and it has to be equal 14e to the 7t. So first I'm going to divide both sides by e to the 7t, because this is common factor for all terms on the left and right hand sides. So basically you can divide both sides by e to the 7t to get 49k plus 21k minus 18k equals 14. And then, of course, I'm going to use my calculator. Minus 18, right? So I'm getting 52k. That's what I'm getting here, equals 14. And then from there, k equals 14 divided by 52. And I have to round to 2 decimal places. Therefore, I'm going to say it's 0.27. Am I correct? Are there any questions? All right, I cannot hear any questions, so I'm going to move to number 2 now. So number 2. So it says here, given is the differential equation, y double prime, I'm copying this down, plus 4y equals 4 minus t. So this is the differential equation. A particular solution is given to you. You don't have to find it. It's given. It's minus t plus 5 over 4. The corresponding homogeneous equation has solution. It's also given. Y homogeneous is C sub 1 e negative 2t plus c sub 2 e, I'm sorry, there's t in front, so t times e to the negative 2t. So that's given, then solution of the inhomogeneous problem. Y of t is the sum, right? So y of t is the total of y homogeneous plus y particular. This is how it works. So it's c sub 1 e negative 2t plus c sub 2t e negative 2t plus the particular solution, which is a fraction. Then solution of the inhomogeneous, okay, so find the constant c sub 2 if y of 0 equals 2, y prime of 0 equals 3, round to 2 decimal places. So we have to find c sub 2, that's the question. If y of 0 equals to 2 and y prime of 0 equals 3. So again, round to 2 decimal places. All right, so I copied this on paper. And tell me where to start. So how do we find this c sub 2 right here?
Yeah, systems of equations.
Take derivative. Did I hear derivative? So we know the solution is given. We don't really have to find it. It's already here. We just need to find this constant c sub 2. And it looks like we'll have to use the initial conditions this time, right? So yes, we need derivative. In fact, yeah, we just need the first derivative. Let's start y prime of t. I'm going to find y prime. So I'm getting minus 2 c sub 1 e negative 2t. Well, this one requires the product rule, right? The second term to differentiate that. So we have plus c sub 2 e negative 2t minus c sub 2t times, well, it's actually 2e negative 2t. And then plus, now this we should probably break into 2 pieces. The first fraction is negative t over 4, so it's negative quarter. And derivative of 5 over 4 is 0. So let me know, do you agree with this derivative? Do you agree with this? Derivative of y, this is our solution y. I differentiated it, right? Used the product rule. And of course, this is derivative of the linear function here, so negative quarter. All right, I'm going to plug in 0 into the function y. This is our solution, plug in 0, so you get c sub 1 plus 0 and plus 5 quarters, and it's supposed to be equal to 2, am I right?
Right.
So it looks like 2 minus 5 quarters, so 2 is 8 quarters minus 5 quarters. I'm getting 3 over 4. That's my c sub 1. Please let me know if you see any mistakes so we can fix them as soon as possible. So y prime of 0, I'm substituting now 0 for t. So negative 2 c sub 1. I will substitute c sub 1 later. At this point, I just want to plug in 0. The next term is 0 and then minus quarter, and it's supposed to be equal to 3. So again, c sub 1, we already have it. So it's minus 2 3/4 plus c sub 2 minus a quarter equals 3. So well, this is -6/4, and this is -1/4. Looks like -7/4. -6 -1, -7/4. So I believe it's 19/4. Are you getting the same?
Yeah.
Okay, so which one did we have to find? C sub 2, right? So I'm going back to the screen and I'm going to type 19/4. Okay, so any questions here? Number 2. All right, question number 3, decide whether the equation 11, so yeah, this one is, let's see, this one has damping term, this is damping term, this one is omega sub 0 squared. So we need to figure out, is it undamped, overdamped, or critically damped? So tell me how to start here. Let me copy the equation. So yeah, let's see which one is it? Let's see. So this term right here is omega sub 0 squared. Am I right? The natural frequency squared. While this term right here is twice C. C is the damping constant. So by the way, which section of the textbook is this? Let's first identify. Is it 4.4?
Yes.
Very good. You need to first be able to identify where is this problem from which section of the textbook. So yes, 4.4 and page 157, that's a good one. So page 157 shows the equation like this. And on page 160 and 161, page 160, 161, we have the definition of the underdamped, overdamped, and critically damped motions. So tell me how to find C. How to find C. Any suggestions?
11.6 divided by 2.
Exactly, excellent, thank you. So we do that, so we get 5.8, is this correct? And to find omega sub 0, we have to take square root of 33.64. So that will give us square root of 33.64. I'm getting again the same number, 5.8. So can you tell me what does it mean about the case? What does it tell you? What kind of case do we have? Underdamped, overdamped, or critically damped?
Critically damped.
Excellent. This is it. This is critically damped. So critically damped case, and I'm going back to the screen here, and I'm going to choose critically damped case. Perfect. So let's look at any questions. So I'm looking now at question 4. We have mass that is given, it's 0.5 kilograms. And the spring has spring constant is given, it's 9 kilograms per second squared. So the system is displaced 9 meters from its equilibrium position and given initial velocity of 4. Well, velocity is missing units, but yeah, that's okay. It's supposed to be meters per second, but yeah, unfortunately the units are missing. So it looks like we're given the initial displacement, am I right? The system is displaced 9 meters from its equilibrium position. So x of 0 is given, that's 9 meters. And initial velocity, what is initial velocity? It's the derivative of x, right? X prime of 0 is also given, it's 4 meters per second. If there is no damping present, find the amplitude of the resulting motion. So there is no damping, C0, find the amplitude of the resulting motion, round to 2 decimal places. So the amplitude is what we're trying to find in this problem. All right, so to find the amplitude, this is also section 4.4, am I right?
Yeah.
We're going to find amplitude, but first we need to write the equation. So this is the mass plus K is 9 units, X equals 0. This is the equation. We have to divide both sides by 0.5 by the mass. So I want to find omega sub 0. So 9 divided by 0.5 is this 18. Let's see, 9 over 0.5, 18x equals 0. So we can see that this is the natural frequency squared. So you can find the natural frequency omega sub 0 by taking square root of 18. So we can say this is 3 square root of 2, isn't it? Because 18 is 9 times 2 and square root of 9 is 3. So we have the natural frequency of this system. And the next step would be to build characteristic equation. So we're getting 2 complex solutions. So lambda will be plus minus square root of 18i. We can also say plus minus 3 square root of 2 times I. Now tell me, do you agree with these 2 roots? Do you agree with this solution so far?
Yeah.
Very good, thank you. Perfect, so okay, so once we have these, we're ready to write our cosine. This is omega sub 0, right? Omega sub 0, 3 square root of 2 times t. And then c sub 2 sine of the same thing, 3 square root of 2 times t. And so to find c sub 1 and c sub 2, we need to use the initial condition. So x prime of t equals, this is negative actually, 3 square root of t sine of 3 square root of 2 times t. And here we have, let me write on the next line. So we have plus c sub 2 3 square root of t cosine of 3 square root of t square root of 2 times t. So do you agree with this derivative? Any questions? All right, I'm plugging in 0 for t. So we're supposed to get 9. X of 0 will be c sub 1, which is equal to 9, and x prime of 0. Well, this term will be 0. We get c sub 2 times 3 square root of 2 equals 4. So we have c sub 1 and we have c sub 2 equals, should be 4 here, 4 over 3 square root of 2. Are there any questions so far? Are there any questions? All right, so once you have c sub 1 and c sub 2, you're ready to find amplitude. So I take square root, and I'm going to add c sub 1 squared plus c sub 2 squared. Are you with me?
Yes.
Thank you. So 16, and then here we have 9 times 2. Square root 8 1 plus, this is 8 ninths. So yeah, a little more than 9. Let me find this calculator. I'm typing square root. Under the root I have 81 plus 8 divided by 9, close parentheses, and I'm getting 9.05. I have to round to 2 decimal places. That's why I'm getting 9.05. Let me return back to this screen here and type 9.05. 9.05. Are there any questions? All right. Well, I'm going to move to the next question, which is number 5. Unfortunately, the numbers have changed, right? The only, let's see, so you can see that the spring constant slightly changed. Initial velocity is different and initial displacement is different. Other than that, it's pretty much the same problem. So the question here is to find the phase of the resulting motion. So the phase is when you have to use arctangent of c sub 2 over c sub 1. In other words, you have to go through the same process finding c sub 1, c sub 2, and then take arctangent of the ratio. So let me copy the information here. So this is number 5. I have the mass is the same, but you can see the constant K is now 8 kilograms per second squared. X of 0 is now 1, and X prime of 0 is equal to 3. We have to find the phase phi, right? Phi is what we're looking in this problem for. Okay. Unfortunately, again, we have to go through the same process one more time. So 0.5 x double prime plus 8x equals 0. I'm dividing both sides by 0.5 to get this equation. This is omega sub 0 now, right? Squared. Oh, but the numbers are better because square root of 16 is actually a perfect perfect integer. So that makes life much easier because our lambdas are now plus minus 4i, and x of t will be c sub 1 cosine of 4t, c sub 2 sine of 4t, and then finally x prime of t will be negative 4c sub 1 sine of 4t, and plus 4c sub 2 cosine of 4t. Are you with me?
Yes.
Very good, thank you. So I went through the same steps and I'm ready to plug in zeros for t. So I'm substituting 0, this term will be 0, so it's c sub 1 equals 1, and x prime of 0 equals, first term is 0, the second term is 4c sub 2, cosine of 0 is 1, equals 3, from which c sub 2 equals 3/4. And the face of this, of course, we have this formula on the index card, right? The formula on the index card, the formula is tedious. This is the formula, I highlighted it, but you should have this on the index card. So did you notice your constants c sub 1 and c sub 2 are both positive? Which means you have to use the first formula right here, the first formula, arctangent, and then you divide the number in front of, I'm going to double check. Yes, b is the number in front of sine, so you divide c sub 2 by c sub 1. C sub 2 divide by c sub 1, and use your calculators to get your number, the face of this harmonic motion. We will have to round to 2 decimal places. So arctangent of 3/4, and I'm getting 0.64. I rounded to 2 decimal places, okay? So returning back to the screen. Well, I'm typing 0.64. And I'm done with this problem. Any questions? Well, there is one more similar question. Number 6 from this quiz, number 6. A 1 kilogram mass is attached to a spring having a spring constant 5 kilograms per second per square second. So I'm copying mass is 1 kilogram and K, the spring constant, is 5 kilograms per second per second. The system is displaced 4 meters from its equilibrium. So x of 0 is given, and the initial velocity x prime of 0 is also given, it's 4. If there is no damping present, find the period of the resulting motion, round to 2 decimal places. Now, this problem is actually very short. A lot of information that you see is redundant. We don't need it, because to find the period, which is usually denoted by capital T, you have to take 2 pi and divide it by omega sub 0. That's how we find the period. So again, period is 2 pi over frequency. And in this case, we're using the natural frequency of the system, omega sub 0. So to find omega sub 0, I'm going to, so we have 1 kilogram, right? 1 kilogram x double prime plus kx equals 0. So x double prime plus 5x equals 0. Looks like this is our omega sub 0 squared. which implies omega sub 0 is equal square root of 5. Am I correct?
Yeah.
Excellent. So the period of this oscillation will be 2 pi over square root of 5. And I'm using my calculator to find it. So it's 2 times pi. And I'm dividing that by square root of 5. I am getting approximately 2.81 if I round to 2 decimal places. So 281, going back to the screen, I'm typing 2.81. And I think I'm done here with this one. Any questions on problem number 6? Well, let's move to the last one. Given is the differential equation, let me copy that. Y double prime plus 4y prime plus 4y equals 2e to the 2t. Use the method of variation of parameters to find v sub 1 of 1. This is what we want to find, v sub 1 evaluated at 1, where the function v sub 1 of t is the one in front of the e to the negative 2t. So you already have the homogeneous solution is given to us. Why homogeneous? We replace c sub 1 by v sub 1, and we replace c sub 2 by v sub 2, round to 2 decimal places. Okay, so I'm going to copy y homogeneous v sub 1 e to the negative 2t and plus v sub 2 times t times e to the negative 2t. All right, so let's, this should look familiar. The problem itself looks very similar to the very first problem that we did today, number 5 from homework. Let's see. We have this system of 2 equations to write. So we know y sub 1 here. Y sub 1 is e to the negative 2t. Y sub 2 in this problem is also given. It's t e to the negative 2t. So those are the fundamental solutions of the homogeneous problem. I'm going back to the very first problem that we did today. This is the system on your index card, right? The system of 2 equations here. So it says v sub 1 prime times y sub 1 plus v sub 2 prime times y sub 2 has to be equal to 0. That's the first equation. And the second one says y sub 1 prime times derivative of y sub 1. So I have to differentiate, right? Plus v sub 2 prime. And then I have to take derivative of y sub 2. So that will be 1 times e negative 2t minus t times 2 e negative 2t. And the right-hand side is supposed to be g of t. So in our case, g of t is 2e to the 2t. So this is the system of 2 equations that we need to use to find v sub 1 and v sub 2. Actually, we only need to find v sub 1 and plug in 1 in there. Okay, we have to evaluate it at 1. All right, I'm going to start. First, let me ask you, do you agree with this? Do you see if anything wrong? Please let me know. Do you agree?
Yes.
Thank you. So let us start with the first. I'm going to subtract the second term from both sides and then divide both sides by e to the negative 2t so we can get rid of it. So it looks like we can substitute instead of v sub 1 prime, we can write minus v sub 2 prime times t. So I'm going to do this now. I'm going to substitute this expression instead of v sub 1 prime in here. So 2t, and then we have v sub 2 prime e negative 2t. And on the right-hand side, we have 2e to the 2t. It's important, can we cancel something? There should be a cancellation. This is a positive term, right? This term is actually positive. And this one is the negative opposite. Am I right?
Yeah.
Excellent. So yes, we can cancel, which actually is very comforting because we know we're supposed to have cancellation. Otherwise, this equation will be impossible to solve. Oh, is it t, 2t or minus 2t? Oh, I think I see a misprint here. Okay. Yeah, I think this problem has a misprint. So let me go back to that. Did I copy it correctly? I don't know what just happened. This one. Let me check, is this positive 2t or negative 2t? Oh, it's positive, right? So I think our answer is not going to match. So I'll have to fix this problem. Well, okay, so let me go back to the statement again. So the statement says negative here, negative here. Okay. Yeah, so this should be minus 2t over here. Anyway, let us continue. So be ready that this problem is going to give you, it's going to say it's wrong because I think I misprinted, I put a misprint in the statement of problem. So again, this problem will probably going to be wrong. The computer will tell us, the software will probably tell us that it's wrong. The reason is that these two are supposed to cancel out. So there should be a minus here, I think. Or there should have been minus over here, because if there was minus over here, then again, the exponents would match. So, so again, be ready for this problem to not be correct. If you don't mind, can I just change this plus to the minus? So I'm going to replace this plus by minus. I think this is where the misprint went. Let me go back again to the statement. So if I would do this, then this will be plus 2 and this will be plus 2. So yeah, I'm changing this to minus instead of plus. So this should have been minus from the start. So minus here, then this will be plus 2 is fine. All of these will become pluses. So this will become a plus. This will become a plus. This is a plus. I apologize if you're writing this in your lecture notes. Please fix it. I did warn you that this test hasn't been, actually, I didn't check. It has to, oh dear, then this will change as well. Okay, so I'll change this to positive 2 and positive 2 here. So this will be positive 2. This will change into a plus right here. And the right-hand side is positive 2t, and then here we will get minus here and minus here. So again, I'm changing these. This should be a plus, isn't it? So this is derivative with a plus because I changed this minus here. So 2t v prime. So you still can cancel. And finally, over here, you're getting a plus 2t. So once I did changes like this, I can now say v sub 2 prime equals 2, and v sub 2 from this equals, after we integrate both sides, is 2t. So this is my v sub 2, and to find v sub 1, because the question was about v sub 1, so to find v sub 1, we have to use this equation here. So v sub 1 prime equals negative. So v sub 2 prime equals 2, so we get 2 times t. And from this, v sub 1 equals, we have to integrate, so it's negative 2t squared over 2. And 2's cancel out, so v sub 1 is equal negative t squared. So the next step is to substitute 1 for t, right? So let me, v sub 1 of 1 will be negative 1. And that's what I'm going to type into this answer box. So I found v sub 1 and I evaluated it. So I'm getting negative 1 over here. Let me ask you, do you have any questions? I apologize, I had to correct so that it's a little messy right now because, again, I had to modify this sign over here. Instead of plus, I put minus. And that means I will have to return back to this problem, change this plus to minus, and change this negative 2t to positive 2t here as well as here. So are you, do you have any questions?
Are you submitting this, like, to see if
yes,
it's wrong? Because I think
I'm
number 2 is something you have to kind of fix. I mean, I think the answer is right, but you wrote it as a fraction, and then I think it's asking for a decimal.
Okay, round to 2 decimal. You're right. Let me. I suspect that computer is going to anyway calculate. You know, the number. It will calculate 19 divided by 4. It says 475. I'm using my calculator. Thank you so much. Let me change that to 4.75. Yes, very good. But it would be a good experiment to leave it as 19 over 4, just to test it out to see what happens. So yeah, I did change it, but I'm curious. It shouldn't give me a mistake if I leave it as 19 over 4. Yeah, very good, excellent. Is there anything else you would like me to change, or any other?
I have a question about number 7.
Yeah, what's the question?
So toward the end, you had canceled out a couple terms, which was v2 prime t times negative 2e. Yeah, that one with the second term.
Yeah.
And what happened to the 2 in front of that? Like, it's 2 times t v 2 prime and all that. Oh, never mind. I see it. I lost that in my first term.
Okay, yeah, they should be negative opposites. We should be able to cancel them completely. Yeah, very good. Yeah?
I had a question. For the quizzes, would it be possible, like this one quiz we had before, where once you take it, it shows you the correct answers? Like which ones you got wrong and which ones you got right? Because for all the prior ones we've taken, it doesn't show, but I feel if we knew which ones we got right, it would be helpful for future ones.
Okay, yeah, let's actually submit and see what happens. I'm going to click on save and submit. Click OK. So I'm going to click OK and see what happens. So I'm going to go back to results and is this what you were telling me? You want to see correct and your own answer?
Yeah.
Okay, yeah, I think this is set up this way as you requested. Well, I see. Oh, okay, so all of them are correct. So that means I still have to change that minus here, okay? So keep in mind, this is not, the statement of problem is not correct because it should have minus in front of 4 here, and it should have plus here and plus here in the exponent, okay? So other than that, it worked out fine. So, well, I consider I tested the quiz, so it will be posted today, probably during the lunch break. I'll just fix a few things here. So yeah, it will be available today. Deadline for this quiz, I believe it states here, the due date is June 10, which is not this week, it's the Wednesday next week, just before the final. So it's technically, you have almost, you have pretty much 1 week, right, to complete it. However, I would strongly suggest that you do at least 1 attempt before the midterm, because your midterm is the day after tomorrow on Thursday, right? So any of these questions you see here, any of these questions could appear on your midterm number 2. Does it make sense? So you need to practice with those questions at home. Try to make at least 1 attempt. You have 3 attempts, but I suggest that you try at least 1 attempt before the midterm, because any of these questions can be on your midterm number 2.
Professor, can you go back to number 7 real quick on the work?
Okay.
Where did the t squared come from?
Which page?
Where you said v1 equals to -2 t squared over 2 on the bottom.
This one? The last line? Okay, so this comes from here. V sub 1, actually, well, technically it comes from the previous line. V sub 1 equals, this is where I integrated, right? V sub 1 prime equals minus, instead of V sub 2 prime, I substituted 2. Because V sub 2 prime equals 2. So I substituted number 2 in here. So I got V sub 1 prime equals minus 2t. And then I integrate both sides. So integrate. And once you integrate, you get V sub 1 equals minus 2 times, antiderivative of t will be t squared over 2. 2's cancel out, and you get V sub 1 equals minus t squared.
Oh, okay. So to solve for v1, you substituted in the derivative of 2t first, and then you just integrated all of it, right?
So yeah, I substituted this number 2 instead of V sub 2 prime in here. And then once I did that, I have this differential equation and I integrate both sides. Yes.
Okay. Thank you.
You're welcome. All right. So any additional questions on quiz number 5?
I do have a question about the midterm.
Yes, what's the question?
What sections will it cover exactly? Like, will it cover like quiz 4 and quiz 5?
So let me see. So midterm, let me write this down over here. Midterm is not ready yet, so but I can certainly tell you. So midterm number 2 will cover starting 2.5. So let me write it over here. So midterm number 2 will be on sections. So we start with 2.5, 2.7, 2.9. This is uniqueness, existence, equilibrium solutions, right? 2.9, 3.1, 3.3. 3.1 is the Malthusian model and also logistic equation. 3.3 personal finance type of problems. We had also 4.1, 3, 4, 5, and 6. So yes, you're right. Quiz number 4, quiz number 5. Yes, quiz 4, quiz quiz number 4 and quiz number 5. Those 2 quizzes you will need to review those, yes. So you review quizzes 4 and 5. All questions will be taken from these 2 quizzes. I don't know if I will include all of the questions, which is probably not very likely.
Isn't it also quiz 3?
So some problems are tedious. So I realize we have about 1 hour and 50 minutes for this midterm. So I will carefully select certain problems. Some problems are very short, and some problems such as multiple choice, right? Some multiple choice are very short, and some require calculations such as logistic equation. So I will carefully choose problems from your quizzes, and that will be your midterm. So midterm is on Thursday. This is our last day. So it's Thursday, June 4th. And your final exam is on Thursday, June 11 from 10 o'clock, right? From it's just regular class time from 10 a.m. to 11:50 a.m. I believe. So I will proctor through Zoom as your first midterm. So any questions?
Will the midterm also
Right.
include?
So again, keep in mind, some problems from these sections are short and some are going to require tedious computation. So I will be careful choosing from the quizzes, right? Quiz 4 and quiz 5. Quiz 5 has 7 problems in it. And quiz 4, well, I would have to go back to take a look there. Probably 5. Your quiz 3, okay, so technically you've been tested on that material on your first midterm. However, solving linear equations, of course, it will be part of your second midterm, because linear equations, all we do is we solve linear equations everywhere. So what I'm saying is, let's say section 3.3, right? Personal finance problems. To solve those differential equations, you have to use integrating factor method, right? Integrating factor method. That comes from section 2.4, which is, covered in the material on the first midterm. So no, technically, quiz 3 stops at 2.4, am I right?
Quiz 3 has the logistic model and
Oh, it does. Oh, I was not aware of that. So logistic model is in quiz 3.
yeah, like sections 2.5.
Oh, okay.
Yeah.
I got it. So I did include 3.1, but not 3.3, right? So yeah, unfortunately, then I have to say it's quiz 3, 4, and 5. 3, 4, and 5. And I didn't remember that. So yeah. So, okay, so quiz 3 included 2.5, 2.7, 2.9, and 3.1. Am I correct?
Yes.
That was quiz 3. Okay, I see now. You had quiz 4. What did quiz 4 include then? 3.3, 4.1, and 4.3. Am I right?
Yeah.
Okay, I got it now. So yeah, that was quiz 4, like this. And this is quiz number, yes, that makes sense now. I'm sorry, yes, you're right. 3, 4, and 5 then. Yeah, 3, 4, and 5. You had 2 quizzes for the first midterm, and it looks like 1, 2, 3 here for the second midterm. Well, let me see. So how about this midterm 2? Let me do this. I'm going to exclude 4.5 and 4.6 from the midterm, but I will include those into the final. Does it make sense?
Yeah.
So one more time. So on your midterm number 2, did everybody notice I crossed out 4.5, 4.6? So these will not be on the midterm. So sections 4.5 and 4.6, even though they're not on your midterm, they're still on your quiz number 5. Does it make sense? So it's still in the quiz number 5. It will not be on the midterm on Thursday, but this will be on your final for sure. Will be included into your final, into final exam on the 11th. All right, so any questions?
So we have to worry about quiz 3, 4, and half of 5?
Yes, exactly. So this is the method of undetermined coefficients. This is the method of variation of parameters. So these 2 methods, they will not be on the midterm, but they are on your quiz 5 and they are on your final exam. Okay, so that's pretty much guaranteed will be there. Okay, so any questions so far? Any questions? Well, I'm going to go back to quiz 4 now. So I go back to quizzes and tests. So I'm going to quiz number 4, and I remember you asked me about the personal finance problem. So begin, and this is quiz number 4. You can see it's displayed one problem at a time. Let me try to find that problem on personal finance. So this is not the one. Let me. yeah, this is on finding the constant K, I believe. Find the spring constant. Okay, this is the one, right? So this is the personal finance problem. You decided that you will need 57,848. So let me start writing. This is number 5 from quiz 4. On your quiz, it could be number 3 or 1. It depends. So you decided that this is your withdrawal, right? Every year you plan to withdraw. Your W is $57,848. You should plan on living for 42 years after your retirement. So you decided that the time, well, you decided that you're going to draw from this account for 42 years. I don't want to say that you plan to live 42 more years and no more. I'm just saying that maybe you have some alternative plans after that. Assuming that your retirement account will earn 4% interest while you're taking this amount each year. So the interest rate is 4%. And of course, we need decimal form 0.04. How much money must be in the retirement account when you retire? So you want to know what is the initial starting amount? How much do you need to have today, right? How much? I mean, if you plan to retire today, you want to know how much do you must have at t equals to 0. So the number of dollars at 0. Round your final answer to the nearest dollar. So please notice this as well. You have to round to the nearest dollar, not to the nearest cent. All right, let me switch to here. And we will construct our differential equation. So it says 4%. So that implies I have 0.04 times P. This is so far doesn't take into consideration any withdrawals. At this point, we just assume we have 4% compounded continuously. And then we have to subtract 57,848 every year. If you want, you can work in thousands of dollars. You could make it 57.848. And in that case, when you type your final answer, make sure you convert back to dollars. And then we want to find P of 0, the initial amount to start with. We know that after 42 years, there will be nothing in this account. So this is the problem we have to solve. Are there any questions? So again, this is the most important part of the problem, is when you set up the differential equation, you need to make sure you understand what is given and what you have to find. Well, I'm going to start solving now. Any questions? All right, so let us find A of t, and after that we'll have to find the integrating factor because this equation is linear. So what is A of t here? Please tell me.
0.04.
Excellent. There you go. And then we know integrating factor is e to the power negative, and then you have your A of t here, dt. So this is what I'm getting for the integrating factor. So as usual, please let me know. If you see something is wrong, please let me know. All right, so I'm going to first I'm going to rewrite my equation this way. So I moved this term right here, I subtracted it from both sides so that we have only all terms containing dp dt and p on the left hand side. So I'm multiplying both sides by this integrating factor. And on the left hand side, we're supposed to have a derivative of a product. So it's p times the integrating factor prime on the left hand side, and the right hand side doesn't change, it's the same. Do you have any questions or any comments? Well, before I proceed, I want to check to make sure we have derivative of a product. So derivative of p times integrating factor, and then we have plus p times derivative of this exponential. So yes, we have minus 0.04 e. Okay, so it looks fine. I'm ready to integrate. And the left-hand side is our product p times the integrating factor. On the right-hand side, this constant will be in the denominator, so we have to divide by negative 0.04. And there will be a constant of integration, we call it c. Are there any questions? All right, so let us, first I will try to see, maybe this is a good number. Negative divided by negative is positive, so 57,848, I'm dividing by 0.04. Well, it's huge, but it's an integer, which is good. So we have p e negative 0.014. And then on the right-hand side, when I divided those numbers here, I got 1,446,200 times e negative 0.04 t, and then plus c. And then I'm going to divide both sides by e to the negative 0.04 t. All right, so here's our general solution. We should be able to find C using this initial condition. So P of 42 equals, I'm going to substitute 42 and solve for C.
Professor, does
Yes?
it, for the C, is it e to the negative 0.04 t, or is it positive?
It's actually positive because let's put it this way, I multiplied both sides by e to the positive 0.04 t to get rid of this here.
Oh, okay. Thank you.
You're welcome. So again, you could say multiply both sides by e to the positive 0.04 t. This way we can cancel this and this, right? But here you will have c times e to the positive 0.04 t. All right, so CE 42 here, and that's supposed to be equal to 0. We're assuming that you deplete the account after 42 years. So I'm going to subtract this number from both sides. And 0.04 times 42 will be 1.68. And finally, divide 1,446,200. Is it, yeah, this is negative, so it's minus. We divide by e to the power 1.68, and I'm getting negative, so 269,534.0441. This is yeah, this is what I'm getting for C. This is C, and the next step will be plug in 0 for T to find the initial starting value in the account. So P of 0, this is what we want to find, P of 0. How much do you need today if you're retiring today? So P of 0, right? So P of 0, I'm substituting 0 for T. So this is 1,446,200 minus 269,534.41, and this is e to the 0. Well, I believe I'm getting 176,665, and well, if we have to round to the nearest dollar, then we will have to say it's 1,176,666. The last digit will be 6 as well. Am I correct? I'm going back to the screen here, right? And I'm going to type this number. Let me copy that. So 1,176,000. Okay, so I'm ready to probably check it. Well, are there any questions? Are there any questions here? Are there any questions here? Please let me know. Okay, so do you have any other questions from quiz 4? This was number, I guess I'm going to save it for now. Let me see if you have any other questions. We'll probably have time for maybe one more question or maybe 2 questions at the most. Is there anything else here? So again, feel free to ask. If you have a question, please let me know.
Can you go over 1 and 2? Because I still have trouble determining linear versus nonlinear.
You know what? I can go over it, but the problem is this quiz is still open, right? Yeah, so I cannot give you the answers to these particular problems because those are, if I solve them, you will get exactly the same questions. So what I can do is I can give you plenty of examples similar to these to discuss nonlinear and linear, which ones are linear, which ones are nonlinear. So again, since this quiz is still open, I cannot tell you which answers are correct because I will be just giving you the answer. These problems will not change. So I am going back here and I'm going to discuss some examples. So let's take a look at the first one. So let's say you have something like this. So tell me, is this linear or non-linear?
Linear.
Linear. Well, let me first.
Isn't it nonlinear because you have cosine of y on the right side?
That's correct. I agree with that. So yeah, you're right. Let me give you here general form g of t y prime. You could have some h of t y equals some fgh, I don't know, let's call it s of t. So if you have something in this form, this should be linear, and it's going to be inhomogeneous if s of t is not 0, right? So this is linear. You could have anything you want in terms of t, right? Could be t to the power of 5. In this case, you have ln of t. In this problem, tangent in front of y prime, you have tangent of t. So this is your s of t. Am I right? Negative t cubed will be s of t. 10 more minutes, okay? Okay. Yes, so this one is linear and inhomogeneous if s of t is not equal to 0. So in our case, your f of t is ln of t, your g of t is tangent of t, and your h of t would be, oh, there is no h of t, right? So this is a cosine of y. This is not a product, by the way. This is not a product. So this is cosine evaluated at y, at your function y. So h of t does not apply here. This does not apply to our equation. So again, if you look here, this is nonlinear. This is non-linear. So again, this equation is non-linear because of this term right here, cosine of y. Function y cannot appear in this fashion here. It has to be in this form, right? But what we have here is not a product. This is cosine of y, which means y is present in non-linear fashion. So this equation is non-linear. However, if I modify this, here is the next example. So you have ln of t, y double prime, plus tangent of t, y prime. And then I'm going to, I'm going to keep my t cube, but I'm going to say this is cosine of t times y. So in this case, we're getting a linear differential equation because all derivatives of y and y itself appear in linear fashion. Is it homogeneous or inhomogeneous?
Inhomogeneous?
Inhomogeneous, very good. So because you have this t cube over here, this will be your, so let me rewrite in this form. So this is ln of t y double prime plus tangent of t y prime minus cosine of t times y equals negative t cubed. So this is your s of t, right? Again, y prime, y double prime all appear in linear fashion. And s of t is not zero, so that means we have linear inhomogeneous equation. So this is linear and inhomogeneous. So any questions regarding these two examples?
What happens if your y value on the right side of the equation is, say, like in a square root or something like that?
Oh, in that case, you're getting nonlinear. Let me give an example here. So this will be one more example. So you're saying if you have square root of y, something like this, right?
Right.
Yeah, let's try it. So if I have something like this, if this is your equation, then this is still nonlinear because function y appears in nonlinear fashion. Square root of y is a nonlinear fashion. So yeah, this term here makes it nonlinear. So E is nonlinear. And similar idea if you have something like this, for example. What do you say? Is this linear or nonlinear?
Linear?
Well, actually,
non-linear.
Yeah. If you multiply like this, it's going to make it nonlinear. So this is nonlinear fashion. If you multiply y prime times y, you're exceeding the exponent. It's not going to be total 1. So yeah, this is nonlinear. Is nonlinear. So any kinds of products of y prime, y double prime will make it nonlinear, or some kind of root, right? Or taking cosine or sine or tangent of y will also make it nonlinear. Okay, so any questions? All right. So I just wanted to summarize one last time, going back to, let's see, to my writing over here.
Professor?
Yeah?
I was wondering, is it possible if midterm 2 was focused on quiz 3 and 4 only, and you saved quiz 5 for the final?
No, this section will be included. 4.4 will be there. So
Okay.
it's going to be, yeah, 3, 4 and section 4.4. This will be included in there. So as before, I'm giving 3 attempts, right? For quiz number 5, 3 attempts. So I recommend to try at least 1 attempt before the midterm. And you still have a few days after that, you can have 2 more attempts for quiz number 5. As a matter of fact, I will probably give you 4 attempts just to, I want to make sure you try quiz 5 before the midterm. So I'll make it 4 attempts for quiz number 5. So yeah, midterm is not going to include 4.5 and 4.6. This will not be on the midterm, but it will be on your final on Thursday, June 11th. Please make sure to review quizzes 3 and 4, and I would again recommend to attempt quiz number 5 at least once. Again, I wouldn't want you to wait with quiz 5 until Wednesday, the 10th of June, because it's too close to the final. I do want you to attempt quiz 5 before the midterm. It will make your preparation for the final easier, because you probably will have more than one final, right? And it's very stressful. So I wanted to actually work on these before at least one attempt before the midterm. So any questions? By the way, I do not plan to extend the deadline for quiz number 5 beyond the final. This is not possible. So this course will end at noon on June 11th. So once we take the final, all the work should be complete by that point. So that's the plan. Are there any questions? All right. Well, in this case, I will probably end this meeting. I will hold office hours next week. They will be slightly different. Monday is as usual, but I will probably have different office hours on Tuesday and Wednesday. So I will email you my schedule, my office hours for the next week. Maybe sometime this week, later this week, you will know my schedule of office hours. I will post an announcement and email it to you, okay? So are there any questions?
Professor,
Yeah?
since you extended the quiz 4, is it possible if you can give one more attempt for quiz 4?
I think I can try to add one more attempt. You're asking for one more?
Yeah, just one more.
I think I can try to do that. Yes, I'll
Please.
I'll try to do that. Yeah.
Okay, thank you so much.
You're welcome. So any other questions? All right, I'm going to stop sharing right now and